Okay, good morning all of you. We are discussing about the states of matter. Another topic is under this one we are discussing about the Boyle's law, Charles law and all gas laws we are discussing as a very easiest topic to get the scoring in the competitive examination. See Boyle's law. So under Boyle's law we are maintaining a temperature is constant. If temperature is constant, what they were telling, volume of a given mass of a gas is inversely proportional to pressure. So then we can write one equation, PV is equals to constant. This is the equation under Boyle's law. The same equation if we can take for same gas at a different condition, we are getting P1 V1 is equals to P2 V2 we are getting for the same gas at two different conditions. Okay, later we are going to discuss some other things is nothing but graphs. When you are maintaining temperature is constant, whatever graphs we are discussing, we are calling them as isotherms. So temperature will be remaining same. Okay, now we can see if we can plot the graph here. I want to tell you something. If x is directly proportional to y, we are getting straight lines. If x is inversely proportional to y, we are getting hyperbolas. Okay, means like this straight line or like this we are getting. Now first graph you see carefully. Now volume is inversely proportional to pressure. For this, if we can take here 1 by pressure on y-axis and volume on x-axis. As the pressure is going on increasing, what happening? Volume will be decreasing. That's calling as hyperbolas. This is the temperature at T1. Another one you are getting like this, another temperature T2. Okay, now what question he may asking in the competitive examination? What is the relation between T1, T2 temperatures? For this, if we can take on any one axis one fixed point. Yes, I am taking here. Yes, from that fixed point draw the line here. This is the nothing but T1 graph, that's why it is nothing but V1, and this is the T2 graph, that's why it is denoted by V2. So what we are getting? V2 from 0, V2 is greater than V1. If what is the relation between volume and temperature? Directly proportional, that's why V2 is more means T2 is more than T1 is a good question. What make graphs is asking. Here we have to float a graph between volume versus 1 by P. Means this is like x, this is like y, directly proportional. Then what we are getting? On y-axis 1 by P, on x-axis I am taking volume, then you are getting straight lines you are getting at T1, T2, T3 temperatures. Now we can fix one point on 1 by P, draw vertical line here. This is nothing but V3, this is nothing but V2, this is nothing but V1. Which is more? V1 is more than V2 is more than V3. Automatically corresponding temperature T1 is more than T2 is more than T3. Over. Are you getting or no? Yes. And I want to tell you some other graphs is nothing but PV versus either P or V. What we are getting? So if you take PV values on y-axis, pressure or volume you have to take on y-axis. PV value will be maintaining always constant. So we are getting T1 temperature, T2 temperature. Is important question, sometimes he is asking. Now you can fix on this y-x-axis any one point. We are getting this is the P1 V1, this is the P2 V2. Which is more? P1 V1 is more than P2 V2. But you are maintaining pressure is constant, means P1 is equals to P2. Then V1 is greater than V2. Automatically T1 is greater than T2 we are getting. All of you clear? Yes. Now I will tell you one more graph is nothing but PV is equals to constant. Apply logarithm on both sides. Log of PV is equals to log of K. Log AB. Log of A plus log of B is equals to log K. Then I want to write down log of P is equals to minus log of V plus log K. This is changing, this is changing. That's why it is similar to y is equals to mx plus c. So then we can take x-axis log v, on y-axis log p. You can take it like this. What we are getting? On x-axis log v values, On y-axis we are getting log p values we are getting. Then you are getting straight lines with negative slope, and whatever intercept is coming here, that intercept is nothing but log of k. What slope you are getting? That is nothing but which one? Minus negative slopes you are getting. These are the graphs related to which one? Boyle's law. After that we are going to discuss about the Charles law. Charles law. Under Charles law we have to maintain pressure is a constant. Okay, if pressure is a constant, volume of a given mass of a gas is directly proportional to absolute temperature. Before deriving this equation, they did one experiment. Volume of a gas at 0 degrees Celsius is nothing but V0. What they were telling, for every 1 degree change in temperature, the volume of gas will be changing 1/273 part of volume of gas at 0 degrees Celsius. For yes, this is important bit. For every 1 degree change in temperature, the volume will be changes how much? 1/273 part of V0. For example, at V1 1 degree Celsius, what we are getting? V0 plus 1/273 of V0. Why? Because temperature increasing, volume is also increasing. How much? 1/273 part of initial volume of the gas at 0 degrees Celsius. If you can take like this 2 degrees, V0 plus 2/273 of V0. Like that you are getting Vt, volume of a gas at T degrees Celsius is nothing but V0 plus T/273 of V0 we are getting. You do it simplification. Volume of a gas at T degrees Celsius is equals to, what is a common? V0 is a common, then you are getting 273 plus T/273 we are getting. So volume of a gas at a particular temperature T is V0 is constant, 273 is constant, we are getting constant. 273 plus T degrees Celsius is nothing but Kelvins, capital T. So that's why we are writing volume of a gas is directly proportional to absolute temperature. But we can write it here, V is equals to KT. That implies V/T is equals to constant. The same equation we are applying at two different conditions. V1/T1 is equals to V2/T2 is a good concept. Okay, what graphs you are getting? Yes, the graphs which will be studied at a constant pressure is calling as isobars. Isobars. Okay, first graph, I want to float a graph versus volume versus temperature in degrees Celsius. Okay, I'm taking volume here directly proportional to volume and temperature. That's why you're getting straight lines. Yes, you are taking volume here, you are taking here temperature, you are taking in degrees Celsius. Then you are getting a straight line. But the straight line after crossing 0, it will be denoted by dotted line. Means is still here gas, but here starts converting into liquid. Okay, now here what happening? The volume of gas becomes 0. Why? Because on this one x-axis point is coming, means y-axis point will be 0. Volume is 0. That is calling as absolute 0 temperature. That value is nothing but minus 273 degrees Celsius. Are you understanding? If you float a graph volume versus temperature in degrees Celsius, we are getting a straight line with positive slope and intercepting on x-axis at minus 273 degrees Celsius. Their volume of a gas is 0. That's why it's calling as absolute 0 temperature. Not like that. I am floating a graph volume versus capital T, means Kelvin scale. Then what happening? Capital T means degrees Celsius into Kelvins means add 273. Minus 273 plus 273 is nothing but 0 Kelvins. That's fine. We are getting a straight line only. Yes, very good. But the straight line is passing through the origin. So they are nothing but P1 and P2. I want to get the relation between P1 P2. Okay, fix any one point on constant. Yes, here we are getting is nothing but which one? T2. This is nothing but T1. Which is more? T1 is more than T2. T1 is more means what we can tell? Corresponding pressure is high. As the temperature is increasing, pressure is also increasing. That's why P1 is greater than P2 we are getting. All of you clear? Yes. Now we can see some other graphs is nothing but V/T versus whether volume or temperature. Yes, if we can take graph like this, volume or temperature, and V by T values taking on y-axis. V by T is always maintaining a constant at pressure P1. This is at pressure P2. This question is asking in Charles' law, while maintaining pressure is constant, if you plot a graph V by T versus P or V by T versus V, if you are taking V by T values on y-axis, then we are getting a straight lines that should be parallel to the x-axis. No, you are taking V by T here. What happening? You are getting straight lines parallel to the y-axis or pressure axis. Are you understanding? Yes, is a very important things. Now later we have to go for third law, Gay-Lussac law. Gay-Lussac's law. Gay-Lussac's law. What is the Gay-Lussac's law? Anybody? Yes, what is the Gay-Lussac law? If you maintain temperature is over, pressure is over, volume is constant. If you are maintaining volume is constant, pressure of a given mass of a gas is directly proportional to absolute temperature, then we are getting P by T is equals to constant. The same concept you are applying at two different conditions, P1 by T1 is equals to P2 by T2 we are getting. The graphs which will be drawn at constant volume, that is calling as isobars. These are calling as isobars. And for example, if you are taking pressure on y-axis, temperature on x-axis, you are getting directly proportional. That's why you are getting straight lines. You are getting like V1, V2 and V3. Okay, now I am taking one fixed point on x-axis. Then this is nothing but P1. This is nothing but P2. This is nothing but P3. Which is more? P3 is more than P2 is more than P1. P3 is more means how is relation with volume? Inversely proportional. Why? Because according to Boyle's law, we are getting V3 is less than, V2 is less than V1 because pressure is inversely proportional to volume concept. After that we are going for one more thing is nothing but Avogadro's law. Avogadro's law. What is the Avogadro's law? Anybody? Yes. At the same temperature and pressure, means we have to maintain the temperature and pressure should be remaining constant. At that same temperature and pressure, volume of a given mass of a gas is directly proportional to number of moles or molecules. What is the meaning of this one? In this room, you are taking, for example, 1 liter of oxygen containing n number of oxygen molecule. You are taking 2 liters of oxygen, then you are getting 2n number of oxygen molecules. That only is telling at the same temperature and pressure, volume of a given mass of a gas is directly proportional to number of moles or molecules. Can be written as volume of a gas is directly proportional to number of moles or molecules. Can be written as V by N is equals to constant. Under same condition for the same gas, if you can take this relation, V1 by N1 is equals to V2 by N2. Are you clear? Yes. This is very important. All gas laws, from this we are deriving ideal gas equation we are deriving. That is very important thing. Okay, let's come to this point. Now we are discussing from this equation we are deciding or discussing about ideal gas equation. So what synopsis I am explaining, you should be strong in that one, then you can enjoy the bits. Ideal gas equation from Boyle's, V is inversely proportional to pressure. From other that one, volume is directly proportional to temperature and volume is directly proportional to N. From all these what we can write, volume is directly proportional to NT by P. Yes or no? We can write one constant. Then we are getting PV is equals to nRT. R is the universal gas constant. This is only we are calling as ideal gas equation. PV is equals to nRT. R is calling as universal gas constant. N is calling as number of moles for the gas. Okay, if you take N is equals to 1 mole, if you take 1 mole of a gas and R is constant, then what we are getting relation at the two different condition, P1 V1 by T1 is equals to P2 V2 by T2 we are getting, that is only calling as combined gas equation. Combined gas equation is a condition in we should take 1 mole gas, that to same gas, and we have to take the R value will be remaining constant. P1 V1 by T1 is equals to P2 V2 by T2 we are getting. So here this is very important bit, R value depending upon units of pressure and volume and as well as temperature. By changing the pressure and volume units at different R values we are getting, I will tell you, R is equals to 0.0821 liter atmosphere Kelvin inverse mole inverse. Directly NEET and CE's examination is asking R values. Okay, now I want, yes, here you are taking volume in liters, pressure in atmosphere. I want to take this value in milliliters. Then what happening in 2000? In 2000 means what you are getting? 82.1 ml, or we can write cc, both are same meaning, atmospheres into Kelvin inverse and mole inverse. No, from this third value, what I want to do, instead of atmosphere, I want to write on millimeters. 1 atmosphere is equals to 760 millimeters or 760 torrs. Substitute. We are getting 62.4 liter as usual. Instead of atmosphere, what we are getting? Torrs, or we can write millimeters and Kelvin inverse and mole inverse. No, I want to get the R value in calories. Most repeated question. 1.987 calories, Kelvin inverse and mole inverse. While solving problem, you are taking approximately 2 calories we are taking. 1.987. Same R value I want in joules. 8.314 joule, Kelvin inverse and mole inverse. Same I want joule in ergs. So 8.3141 joule is equals to 10 to the power of 7 ergs into Kelvin inverse and mole inverse. These are different R values, you have to practice very carefully. All of you understood? Yes, now we are discussing about the things ideal gas. Ideal gas means the gas which obeys all the gas, which obeys all the gas laws at all conditions is calling as ideal gas. Actually, no ideal gas in the universe, like no ideal man in the universe. Everybody has some drawbacks, means some negatives in them. Now we are going to discuss about the Graham's laws. This is important, Graham's law of diffusion. Yes, possibility for the question in competitive. What is the Graham's law? Here we are discussing about the rate of diffusion or effusion. Rate of diffusion or effusion denoted by R. Rate means generally speed. Speed of spreading of gas. How can you measure? Volume occupied by the gas in a particular unit time. In that particular unit time, the gas will be covering how much volume? More volume is covered means more speed. That's only calling as high rate of diffusion. This rate of diffusion of a gas is directly proportional to temperature as well as pressure. As the pressure is increasing, speed increasing. As the temperature is increasing, speed is also going on increasing. Okay, now you can take a rate of diffusion. According to Graham's law, under same condition and temperature, the rate of diffusion of a gas is inversely proportional to square root of density of the gas. You know very well, density is directly proportional to molecular weight, is directly proportional to vapor density. Can we substitute here? R is inversely proportional to square root of density, is inversely proportional to square root of molecular weight, is inversely proportional to square root of vapor density. I am applying the same concept for two different gases. That comparison is important. Then what we are getting, rate of diffusion of a first gas by rate of diffusion of a second gas is equals to square root of density of the second gas by first gas, or nothing but molecular mass of second gas by molecular mass of the first gas, or nothing but vapor density of the second gas by vapor density of the first gas we are getting. This is the important relation. Is it clear? Yes. Now we are going to discuss some other things. So one thing I want to tell you here, if suppose gases are traveling same volume in different time means T1 is not equals to T2 but V1 is equals to V2. Then what we are getting? Rate of diffusion R1 by R2 is equals to V1 equals to V2. No, cancel. Then what you are getting? Yes, V1 by T1. Okay, means V2 by T2 means T2 comes up. T2 by T1 is equals to square root of M2 by M1 as the remaining formula will be coming. Another case, gases are traveling same time but different volumes, occupying or spreading different volumes. What we can tell? V1 is not equals to V2 but T1 is equals to T2. Then R1 by R2 means formula volume by time. Volume will be remaining, volume is not equal, time is same. So then what we are getting? V1 by V2 is equals to square root of molecular mass of second gas by molecular mass of the first gas. All are very, very important. And the same rate will be also affected with time, means temperature and pressure. The rate of diffusion of a first gas by second gas is equals to pressure of first gas by pressure of second gas and the square root of molecular mass of second gas by molecular mass of first gas. Now how relation with temperature? Rate of diffusion of a first gas by second gas is equals to, always speed is directly proportional to under square root of temperature. It will be coming in the KMT, kinetic molecular theory of gases. Then we are getting T1 into M2 by T2 into M1 will be coming. These all formulas is very, very helpful to us. And what are the applications of this one? This Graham's law we are using in coal mines. In coal mines for the detection of marsh gas. Marsh gas means is nothing but formula CH4. It is detected by using ANSIL alarm. ANSIL alarm. What happening in the coal mines? The carbon is there and at high temperature combining with hydrogen and forming methane gas, marsh gas is a poisonous gas. That's why when this gas will touch that ANSIL alarm start ringing, everybody will be alert. It is used in the atomolysis. Atomolysis means is nothing but separation of isotopes. For example, uranium 90 to 235 and uranium 90 to 238 is there. Separation will be very difficult but possible according to rate of diffusion concept. It will be treated with which one? Fluorine. Actually is a solid, no? After reaction they are becoming gases. Those gases passed through a pipe and which will be moving fast, lightweight. That's why which is coming outside first? Uranium 90 to 235 will be coming outside first and whatever remaining will be there, uranium 238 still remaining in the pipe. Like that we can separate the constant particle from the mixer. All of you clear? Yes. Now we are going to discuss about another one is nothing but Dalton's law. Dalton's law. What is the Dalton's law? The Dalton's law is applicable for the non-reacting gases mixer. Later we can discuss what is the law non-reacting gases mixer. Okay, which are reacting gases? Reacting gases means the Dalton law is not applicable. What are the reacting gases? Highly reactive chemicals. Do you know? If you can take CO plus Cl2, the Dalton's law is not applicable. Why? Because they combining together and gives new component at ordinary condition. If you can take H2 and Cl2, easily reacting, that's why we can't apply the Dalton's law. Like that we can tell H2 plus F2 and you can take NH3 plus HCl and like that we can tell NH3 plus HF. These all is highly reactive gases, that's why the Dalton's law is not applicable. And to whom we can apply the Dalton's law means non-reacting gases. Sometimes he is asking this one as a bit. So for non-reacting gases mixture we can apply the Dalton's law. So H2 plus O2 combination. H2 plus O2 is directly combining? Never. So it will require some drastical conditions. And if you can take like N2 plus O2 and you can take N2 plus H2 and you can take CO2 plus O2. Okay, you can take so many examples, H2 plus He and H2 plus neon. These all are non-reacting gases mixture. That's why for all of them we can apply the Dalton's law. According to Dalton's law, in case of non-reacting gases mixture, the total pressure of a gases mixture is equals to sum of partial pressures of all gases in it. Okay, what is that one? P total. Total pressure is equals to partial pressure of A gas plus partial pressure of B gas. What is the meaning of partial pressure? Partial pressure means the pressure exerted, individual pressure or alone pressure it is actually. So pressure which is exerted by a gas when you taken that one in a container as like mixer. For example, you have a mixer. In that mixer A gas is there, B gas is there. Okay, that means if you can take, we are getting pressure is total pressure we are getting. Total pressure we are getting. But what is the meaning of partial pressure? In the same SV liter container, in the same B liter container, we have to take A gas alone. Then creating pressure is calling as partial pressure. The partial pressure of A gas is directly proportional to from ideal gas equation PV is equals to nRT. From there you are getting partial pressure is equals to number of moles of A gas RT by V. Okay, like that partial pressure of B gas is equals to N of B into RT by V. You can do it. Total pressure P total is equals to PA plus PB. Then you are getting N of A plus N of B into RT by V. The total pressure is equals to total number of moles into RT by V. This one we are getting.